everyone, this video is about the classic Casio fx-602P programmable scientific calculator, which was on the market from 1981 to 1989. And the 602P was the successor to the 502P, and it was the first Casio calculator to support alpha characters. And it combined this with a high contrast dot matrix display, a powerful keystroke programming model, and a generous amount of memory for its time. It also supported input and output to tape and printer. And it combined these features into a very compact form factor. During the 80s, it was a competitor to the HP 41C family of calculators, as well as the TI-95 ProCalc. And it really provided great value for money, costing around 85 British pounds in 1981. It has the reputation of being one of the best calculators Casio has ever released. So physically, as I mentioned, the 602P is very compact and thin. The calculator is 15 centimeters by 7.6, which is very similar width and height to this 41CX, but it's considerably thinner at only 1.2 centimeters. Most of its casing is made from aluminium back and front plates, and it's quite sturdy. There's a physical on-off slider, and on the top edge is a port for connecting to an FA1 or FA2 cassette interface, which I'll demo later in the video. And you can also connect to a Casio FP10 printer, and it weighs only 100 grams. The 602P display has an impressively high contrast LCD that can display 11 alphanumeric characters plus a 2-digit exponent. Each character is a 7 by 5 dot matrix. And on the bottom right of the display is the word lithium, referring to the battery type. Below the display is also a reference in very small text for the calculator's modes. The keyboard is organized into three sections. The top two rows are mostly related to programming, with the top row providing shortcut keys to 10 program spaces. The middle section are scientific and memory keys, and the bottom section is a keypad with larger buttons. And there's a brown inverse key which also acts as a generic shift key. And hitting this along with the modes key switches to alpha mode. And the keyboard uses the usual Casio plastic keys, but they seem bounce free, and I've never noticed any missed or repeated keystrokes. And overall, the keyboard is quite similar to its predecessor, the major difference being the inclusion of alpha characters. And it didn't require a keyboard overlay like the 502P, but it did support a music overlay for making sound through the FA1 cassette adapter. And the 602P takes two 3-volt CR2032 lithium cells that provide approximately 660 hours of continuous use. This was different from the older 502P, which took alkaline batteries. And the fx-602P came in a folding Casio-style leather wallet. So the fx-602P is a modal calculator, and modes were a feature of the Casio calculators all the way back to the original 201P programmable from 1976. And the main modes are run, write, and program control. But you can also use the mode key to change between degrees, radians, and gradians, and also write into memory. So we can hit mode 1 now to make sure we're in run mode. And here we can use the calculator in the traditional way, and the 602P supports algebraic entry and order of operations. So say 2 plus 3 times 4, and then equals 14. And the 602P has 11 registers that store 11 levels of parentheses or high precedence data. And interestingly, when the left bracket is hit, the calculator will display the level, and then when the right bracket is hit, the calculator will display the intermediate result. Scientific functions are entered postfix, so for example 45 sine, or functions that take two arguments, so say x to the power of y, are entered infix, so let's say 2 to the power of 3. And the value displayed is always the value of the x register, but there's also a y register that is useful for storing rectangular or polar coordinates. The 602P doesn't have built-in support for complex vector or matrix operations, and if those are required, they would need to be programmed, and there are some programs that come with the 602P for complex operations as part of its program library. As I mentioned, the 602P was the first Casio calculator with support for alpha strings, and text can be used within programs to prompt for input and also to augment output. But the device doesn't have a programmable string register per se, but it does have commands to merge numeric values from the X register or memory with the strings that have been entered. So to enter an alpha string, you hit inverse and then mode to go into alpha mode, and then I can type characters from the upper section of the keyboard, and if I prepend those with the inverse key, you get the lowercase variants. And using the inverse key with keys from the keypad allows inputs of various symbols, as well as the space character. There are some special command characters that can be entered into a string. So for example, the percentage character will substitute in the numeric value from the X register into the alpha text. So for example, if we exit out of alpha mode and perform a calculation, let's say 5 times 100 and then equals, and say we wanted to present that value formatted as the value of a symbol D with units of kilometers, we can switch back to alpha mode, and we can type in, let's say D equals, and then we can hit the percentage key, and then we can type in KM. And there's also a similar command for substituting in values from particular numbered memory registers. If you've watched my video on the TI-95 ProCalc, this is a very similar approach to how that device supports alphanumerics. And the 602P and its successor, the 603P, were the last Casio calculators to support a keystroke programming model. And the 602P supported fully merged operations. So, for example, inverse sine would be represented as one operation rather than two. And although the device supported more than 256 operations, it represents all the most common ones as a single byte. This makes programs very memory efficient. And various styles of synthetic programming are possible, and I'll talk more about those later. The 602P's programming model is quite simple and elegant, with a small but powerful set of commands. And there are 10 program spaces, and each program can support up to 10 numeric labels. Programs can invoke each other via the go sub command. And the 602P supports indirect memory addressing and indirect jumps. And also supports compact loops via the ISZ and DSZ commands. And I'll start with my favorite simple programming example, the full distance equation, which calculates the distance an object falls under gravity in time t. And so to create a program, we enter write mode 2. And we'll pick our program space, so let's pick P0. And now we can enter our keystrokes. So we'll start by prompting for time t. So we'll enter in alpha mode and type t equals, exit alpha mode, and then halt for input. Once we've got input, we'll calculate the distance d, which is t multiplied by half, and then by 9.8. And then squared, and then equals. And now we'll present the results back to the user by merging the value that's now in the X register with some text. So again, we'll switch to alpha mode and then type in D equals, and we'll use the percentage character to substitute in the value from our register, and then again exit out of alpha mode. And that's the end of the program, and we can use the backward step or forward step to scroll through the program steps, and you can delete and insert instructions at any point. And I quite like the horizontally scrolling experience, which the 602P shares with the TI-95 Pro Calc. And so to run the program, we can switch back into run mode 0, and then we just hit the P0 key, and we're prompted for T, so let's enter say 10 seconds and then hit EXE, and the distance fallen is 480 meters. And we'll move on now to a more complex example, so a program that's a solution to the N-Queens puzzle. And N-Queens is a chess puzzle that involves placing N-Queen pieces onto a chessboard so that none are attacking each other. For example, one solution for the 8 queens is when queens are on files 8, 4, 1, 3, 6, 2, 7, and 5. And in this case, none are on the same rank, file, or diagonal. And the 602P program I've got to produce the solution is very compact, and it shows some key features of its programming model. In particular, indirect addressing using memory registers 00 and 09, and these are used as pointers into ranks within the solution space. There's also use of memory register 0F for comparison tests, and in this case it stores N, which is 8. And the program also keeps a loop counter at memory address 1F. And I won't go through the program line by line, but the general approach is to fill memory registers 1 through 8 with the solution. So register 00 points to the current rank within the search tree, and the program terminates when this gets to 8. And register 09 is used to loop through the past queens that have been placed in order to make sure that none are attacking the new queen. There's also code from label 4 onwards that prints out the 8 memory registers that contain the solution. So if I switch to mode 1 now, I can hit F9 to run the solution, and it takes 7 minutes and 45 seconds to find the solution, so I'll skip ahead now. And so the program's finished running now, and the solution it found has queens on files 8, 4, 1, 3, 6, 2, 7, and 5. And 7 minutes sounds like a long time, but this is blazingly fast compared to other calculators from the early 80s. So for example, the 41C takes 17 minutes to run a similar keystroke programming, and the HP 15C 1 hour and 19 minutes. And it's possible to use synthetic and undocumented programming techniques on the 602P, and you can categorize these into 2 types. So first category around the way instructions can be combined together in undocumented ways. So for example, the 602P has an x equals f condition operation. Now if you wanted to do something when x is not f, the documented way to do that would look something like this. But there's actually a much shorter way, that depends on the way that the X register changes after conditions are evaluated. And there are quite a few tricks like that, especially with chaining condition statements. Second category is the more traditional type of synthetic programming involving the use of undocumented opcodes. And this is possible on the device, but wasn't easy to do or common. So one method is to create a custom programming using a sound generator and loading it in via the cassette adapter. There's also another method involving quirks of write mode 3, and the general idea is that characters within a string in a program can get interpreted as program opcodes if the calculator is turned off in certain states of string editing. Now, I've read about this technique, but I haven't been able to find simple repeatable instructions on how to accomplish it. If anyone knows more about that technique, please let me know in the comments. But people have documented all the functions for each synthetic and non-synthetic opcodes, and I'll link to those within the video description. So this is the FA2 cassette adapter, and the calculator plugs into this via a 6-pin port on its top edge. And the primary function of this is to allow loading and saving of programs and data to tape. And a separate tape recorder is required. I've currently got the FA2's white output cord plugged into a speaker so we can hear its output. So for example, to save a program, we could hit record on our tape recorder, and then we're just going to go into mode 3 and hit save in exe. And the data is output using KCS, or the Kansas City Standard, and this was a way of storing digital data on tape at a rate of 300 bits per second. And loading a program involves pressing play on the tape and loading it on the calculator. But nowadays you don't actually need a tape recorder to use the FA2 adapter. Instead you can just plug in the lines into a computer and record and play sound files. So online you can find some programs for the 602P in MP3 format. And the 602P and FA2 also support a special mode where you can output music. And this requires writing special programs on the calculator, and the programs use normal functions that get reinterpreted as notes. And so to output a note, the calculator needs a pitch and duration. And so you store the pitches of the notes in memory addresses, and the memory opcode determines the note length. So for example, if I look at one of my programs, and MR corresponds to a crotchet, and it's pointing to memory address 3, which is the C note. And MIN is a quaver, I believe. So to run the program, we'll go to mode 1, and you need to set the setting to music on the FA2, and then you can just run it. So in summary, the Casio fx-602P is a great calculator, and it developed a cult status through the 80s that to some extent remains to this day. And in this way, it has a lot in common with the HP 41C and the TI 95. As far as I know, these, along with the 602P's successor, the 603P, were the only traditional calculators ever made that supported alpha characters, indirect addressing, and input-output. This combination of features made them really unique in terms of their power as general-purpose computing devices. Late in the 80s, pocket computers with QWERTY keyboards replaced the same level of functionality in a different form factor, and traditional calculators came with more built-in features such as complex vector and matrix support, but without the same level of expandability. And so Casio themselves went in a number of directions in the mid-80s with their calculators, and starting with the fx-602P, keystroke programables transitioned to real pocket computers, but also Casio continued to evolve its programmable calculator line with the great fx-4000P. That also had alpha support but adopted a tokenized programming language, and that continued through to the fx-4800P. That brought a lot more built-in functionality, and that line continues to this day with the 5800P. And Casio also released a successor to the 602P much later in 1990 in the form of the rare fx-603P. And this was very similar in functionality, but was less compact and had a two-line display. And so I hope you've enjoyed this video and found it useful, and if you have, please subscribe to the channel and hit the notification bell to get alerted of new videos.